Okay. Let's see, I'm a little confused with my captions here. Oh, hide captions, I think does it. Okay. Um, so let us begin here. And we're going to start out with this is module 9. This is November 18th, 2024. And we're working on module 9. Module 8 went astray. My lecture for module 8 went astray, but the lecture from last year was perfectly fine. So let me go over introductory remarks here. Next week is Thanksgiving, right? I hope, I think. Let's look up Thanksgiving. Yeah, next week's Thanksgiving. November 28th. So that's next week. Okay. What I usually do for Thanksgiving week is that is a catch-up week, giving you time to catch up on everything. If you're behind on anything, get it in. If you haven't done quizzes, get a hold of me. I will reopen the quizzes for you. Get everything in you can. And remember, my grading system is based very heavily on getting things finished and accomplished, and not so much on points, not so much on the details, but you can't have missing assignments. At least, it will be reflected in your grade. And on Monday, I will give a talk on something. Does anybody have a favorite topic that I should talk on? If not, I've got a couple possibilities. Either I'd like to talk about BTRFS. That's what I'm trying to get where I'm using it in a more sophisticated manner. I've been using it for at least 5 years now, maybe more, but I don't use it very elaborately at this point. BTRFS will let you do snapshots of your file system. It will also let you do, and it will let you do everything LVM does. It will also let you set up, well, it says it will let you set up RAID devices. I wouldn't trust it for like level 5 RAID. They've had a few problems with it with some of the RAID levels, but disk mirroring works great in it. And I've been using disk mirroring for a long time with no problems with BTRFS. In terms of is BTRFS ready for production usage, Red Hat says no. SUSE says absolutely. That's their default. And I tend to think it is ready for production usage. As I understand, most all of Facebook's machines are using BTRFS. If it will stand Facebook, Facebook uses it in production, so it's ready for production. However, I wouldn't use it for RAID level 5, or well, for the only RAID level I'd use with it is disk mirroring. Okay. So next week is family time. I will have class on Monday. I will be around for my a coffee with Dave on Monday. On the other coffee with Dave is scheduled for Thursday. I will not be here on a week from Thursday because that's sort of like Thanksgiving. um, and so for you, it's a catch-up week and a chance to work on your final presentation. Now, I'll say a few words about some problem I had. I had a problem, my system did not reboot, and I'm still a little nervous about my system. But for some reason, I decided to reboot my system. I don't think I'd booted it in quite a while, and it did not reboot. And I couldn't figure out why it wouldn't reboot, and I was frustrated by the whole experience. I sort of think I know why it wouldn't reboot now, and I'm a little ticked off at OpenSUSE if that's the reason. But because it would be a bug if that's the reason. In any case, I seem to have lost my boot record, or at least, more likely, I lost access to my boot record. And things did not boot right. Well, neither here nor there. I did have good backups of all my data, but I didn't have backups in a really well-organized manner where I could back up instantly. Had this been a professional setting where I had a professional budget to run things, I would have had an identical disk, which in theory would have booted me up. I'd just throw in a new disk, I'm booting up, and it runs. And I could put it on another computer, so if I had hardware failures, it would run. I don't have an infinite supply of disk. I've got a fairly large supply of disk for an individual user, but it's far from infinite. And so I didn't have an identical disk. And as it turns out, if the error is what I think it was, an identical disk wouldn't actually have not helped me. But had I been playing war games properly, in other words, testing things out, testing my backups, testing my disaster control system, I would have caught it. Which is the point being, actually, I had my data backed up. That's sufficient. But if you really want to come up really quickly, like at a professional level, you need a lot of redundancy. You need redundant disk, you need redundant hardware. You need quite a bit of redundancy. Often your redundancy is going to be baling wired because that's probably all your budget will allow. But you do need quite a bit of redundancy. The other thing you need that I did not have, I'm afraid, is if you have I'll use the term expensive piece of equipment. Back in the old days, I always said, if I have any piece of equipment more than $10,000, which was quite a bit of money in the 1980s, but if I had any piece of equipment worth more than, say, $10,000, it should have a separate logbook, which I always stored beside the machine, that everybody was supposed to write in when there was some quirk with the machine, or if it was like a printer that needed to be cleaned or a plotter that needed to be cleaned, there would be a record of when it was last cleaned, who did the cleaning, basically a record of everything. And every computer really, if it's an important computer, you really ought to have some record of what you've done with the computer. In particular, what I did not have a good record of is what software I had on the computer. Because, yeah, I brought up, I installed Linux and I think VirtualBox I installed OpenSUSE 15.6 Leap, I think it was. I could remember that, and I had VirtualBox and QGIS and a couple other things. But the truth is, I'd probably installed 100 different software packages that I was actually using for something, and I couldn't remember what I'd installed. Had my records been better, as they should be, it would have saved me at least a day's time. And I still don't have everything quite back to normal, because when I go over here and try to watch a video that I made, I don't, it gives me an error message, and I don't exactly have that figured out, why it's giving me that error message. It is clear that I do not have some codec installed that should be installed, but I thought I installed every codec in the world. And there's clearly one missing that I need. And after class, I'm going to get it. But so anyway, that's the importance of logbooks and just keeping records on things. I don't know that I would keep things as a log book nowadays. I tend to keep things in a file, but that file should not be on the computer that it is you don't want it on the computer that it's keeping a record of, because if that computer goes down, that file is inaccessible, and that's the exact thing you need to bring it up. So it should be on a file server someplace. Put it in the cloud. The cloud, it's secure. Nothing's ever going to happen until they decide they want to charge you more money for the cloud. Yeah, anyway, my point is, put it someplace secure, and keep it someplace secure. If you've got 2 or 3 computer systems, that's not hard, because you keep it on a different system than the one you're on. Okay. Okay, module 8, as a result, I didn't get a new module 8 video made, but I think last year's video is quite sufficient, and should work for us. Next item is, we are actually getting close to the end of the term. So with the end of the term, we need to start thinking, or you need to start thinking about scheduling your final presentations. I will, one of these days, it's not a hurry, but certainly by next week, I will put a little blurb up on the news giving you a link to where the presentation, or where you can schedule those. But for the time being, if we go over here to our class Desire to Learn site, and we go to Module 9, in the Module 9 introduction, there is a place, there's a link here for scheduling your final presentation. And all that does is it brings up a spreadsheet. If I've done this spreadsheet correctly, I have shared it with everybody so that everybody can edit this, as Victoria already has done. And you just schedule a time slot. And I'll probably open up part of that Sunday if anybody wants it. Although Sunday is kind of my day, so for family activities and things. Anyway, that's all there is to it. And if you can't do it, then you need to make special arrangements with me when you can do it or something. Or there are probably a couple people that really can't do it live for some reason, and there's an alternative. At least not in general, but if there is a real good reason, there's an alternative. Okay, let us go back to our little blurb here. So, what we have here is let's just a quick overview of what we didn't do in Module 8. Module 8, Chapter 7 was on managing basic storage, and that's the stuff that I went over before we ever got to Module 7 on how you use fdisk to partition a disk drive, and then you use mkfs.ext4 or BTRFS or x.fxs, whatever format you're trying to format that disk in. You use mkfs dot whatever format, and then you can use that command to format your disk. And once your disk is formatted, then you can put stuff on the disk if you want, but you need to use the mount command to mount your disk, or the umount command to take the disk off the system. And you really always want to use umount before you turn off the power button, because that helps keep your disk from getting chopped up, from losing information, just like if you have an NTFS disk in Windows, or even an MS-DOS disk in Windows. And to mount your disk at boot time automatically, you have to edit the file /etc/fstab. And that file /etc/fstab is an important file. That's also a file that you edit very carefully, because if that file is if it's got a bad error in it, I haven't tried this lately. I haven't had an error in a while, but if it's got a bad error, your system just does not boot right. And I think they've improved that from the way it used to be, but your system doesn't boot right. And most frustrating is it starts giving you error messages that have nothing to do with your FS tab file. So it gives you very misleading error messages, or at least it used to give you very misleading error messages, which was really terrible. But so that's a file you really want to edit carefully. And okay, chapter 8 is on was on LVM, Logical Volume Manager, and I gave you a couple of videos on that, and I think the videos are better than anything I would say on LVM, especially today, since LVM is, I don't know. LVM is, what do you say? It's logical, it makes sense, it's easy, but it's an abstraction of the basic storage stuff that you do in chapter 7. And it's enough of an abstraction that it gets confusing. It's very easy to get a little confused, even though it really is pretty simple. And the result is I've always had a love-hate relationship with LVM. Way back when I decided I was going to make all of my disk LVM, and I did that, and they worked great. That was before anybody was using LVM as their default, like Red Hat does today. And then I went to systems that I wanted to put out on user sites where I did not have many highly skilled people at those sites. And I decided LVM was just what did I say? A needless impediment to getting everything done right. So I was better not using LVM than, so I moved away from LVM. And to show you I have a love-hate relationship with it, I just told you almost all of my stuff is BTRFS, which is actually LVM, but 2 or 3 steps higher than LVM is. It's a lot more complex than LVM. So there's real reasons to use LVM, but there's also real reasons not to use LVM. It's a matter of balance. And then chapter 9, we talked about, well, we didn't talk about anything this year because we didn't do that lecture because of the holidays. But that was on NFS and SMB and things like that. The book has a fancy name for that. What's the book called that? Let me go over and look at our book. I don't think I'm logged on here. Nope. I gotta log off. Log back on. That must be about chapter 9. Yes. The book calls that network attached storage. I guess that's fine. I just think it's a fancy name for what we're doing. There are several types of network attached storage. Usually network attached storage is just a little box, a little device that has, I guess, a little computer running Linux probably, and some disk drives in it. And they're probably rated, and maybe they're using fancy storage techniques like LVM or whatever. And then they apportion those disks. Well, then there's various ways of sending information from those disks to client to your network of client computers. One way of sending things is by either using window shares, which we call SMB, that's the protocol, or by using if they're Linux machines or any type of Unix machines, or even if it was around anymore, even proprietary operating systems that are not Linux or Unix. We would use Network File Service, NFS. In fact, Windows nowadays uses NFS too. I don't know how much they use it, but it looks to me like they're more and more they're moving to NFS. And if all you're doing is NFS, I hate to use the term network attached storage. I guess it's fine. It is. I just call that a file server. But I would say the other way of going that I'm not prepared to talk about, but there's something called iSCSI, where you can take your disk drive and you can apportion portions of that disk drive, well, your stack of disk drives on the network attached storage. You can proportion portions of that to various workstations, and they will look like a disk to the workstation. Not like files, but like a disk. So the workstation itself will have to format that disk and use that disk and mount that disk. And it will be a mount command and a format, an MKFS command, and it will look just like a disk drive to that computer. And it's a way of centralizing your storage. And I sort of think of that as more the network attached storage, but I guess they're both network attached storages. Anyway, NFS is something we've been doing for 100 years now. The first time I ever ran into NFS was in the early 1980s, maybe. It was a long time ago. NFS has been around for a long time. It's really a good protocol for, and it allows you to basically share or share a disk to share a file system to multiple workstations, or one workstation or multiple workstations, and one good use of NFS, if this isn't too abstract to make sense, suppose I have 100 Linux workstations. We're going to keep it simple. They're all Linux workstations. I've got 100 of them. And I've got 100 users, but I don't know which user is sitting at which workstation, because they come in and they play musical chairs. I never know who's sitting where, but I want all these users to be on the system. I'd like all these users to be able to use their system, but their system, but they're not sitting at the same spot. So what I do is all of their files are going to be in the home directory, right? It will be like /home/ /dmandel /home /insmith /home /joe. Okay, so what I will do then is that slash home, I put that onto a file server and I try to get myself a fast hard disk like an SSD, and I pay some real money for the hard disk. And maybe I even put it on a mirrored hard disk because I don't want things to really screw up. And that will also improve my access speed. And then I put that on a file server, and then I use NFS to put slash home on every one of my 100 workstations. So every one of those workstations is accessing the same slash home. So if Joe comes in, he sits at one workstation, he logs on, he has his slash home slash Joe. He sits at a different workstation, he logs on, he still has his slash home slash Joe. That is very commonly done. And I don't personally do that because it doesn't fit my needs. And actually, it doesn't fit the needs of most systems I've worked on. But I bet more systems do that. More professional systems have the shared slash home than don't. I'm not sure. That's just a very common usage. It works really well. And in fact, what I do have is I have a huge, well, let me go to an area here. I don't know. I have an area called slash alt home, and yeah, the books say never make a top level directory, but that a lot of textbooks say, you know, as a user, never make a top level directory. As a systems administrator, never make a new top level directory. Once in a while, it's a good thing to do. This is that once in a while. Don't make many of them, but once in a while, it's a good thing to do. Okay, anyway, down here, I have my home directory. I've got a lot of stuff. Actually, I've got a lot of stuff there. That is my data directory. And I share that among most all of my computers. Well, at least my private computers. So I can access that data from anywhere. And that's just really common. And the book describes how you do that in chapter 7 in detail. Any questions? I will add two things about this. You do have to give access rights to before you can do an NFS mount, because you're mounting across the file network. And the file you have to edit to give give access rights to another computer is called /etc/exports. /etc/exports. That's described in chapter 9 of the book. Something else came to my mind at the moment, but and that is and then by default, the data is transferred without encryption. And I think maybe the newest standard, NFS standard 4, I think may have encryption built into it. But in the past, if you needed encryption, we would throw Kerberos on everything to get us encryption. There's ways of getting encryption, but you know, for a lot of our local area networks, we don't really have to worry about encryption too much locally. Once you go over a broadband, you need to worry about encryption. So, and NFS does work across the internet. It's just fine. Although even there, I would probably pipe it through a VPN, and that will give you that will secure everything. Just putting it through your VPN. Next item. Next item is controlling our boot process. The book describes this and does a good job describing it. And I'm just going to add a few things to what happens here. The first thing is everything the book describes is using a bootloader called Grub. Now, the way the boot process works, if we go down into chapter 10 of our book, on chapter 10 of our book, it's got a diagram here. The way the boot process works on a computer is you turn on your power, it does post, which basically checks your hardware, initializes your hardware, and then it goes into a program on some chip that basically says start getting information off the disk and put an operating system on the thing. Well, this is called your BIOS software. At least it used to be called our BIOS software, but the BIOS software had limitations, so they've come up with a new system. We've had it for a good many years now, called UEFI, which is an alternative system of booting your computer. So there's really a couple different ways of booting your computer. There's the old system using BIOS, which then reads the data from off the disk from something called an MBR, which is on, as I recall, the MBR itself is the first 512 bytes on the beginning of your disk. And that is painfully small. Painfully small. And that is the reason why on old style MBR type disk, we're only allowed to have 4 partitions. And 4 partitions didn't work very well, so they take one of those partitions and they allow us to have subpartitions in that partition, which we call extended partitions, so that we could have more than 4 partitions. I think the book said we could have 16 or something. I don't really agree with the book there entirely. The book is right, except as I recall, the number of partitions you were actually allowed depended on what sort of interface you were using to your disk drive. You were allowed 16 or something partitions if you had a SATA disk interface to the disk drive, like we use nowadays. But there were a SCSI interface. I thought it was 64. I don't remember. But it depended on the interface. That's much more standardized now. Anyway, today most people are using I thought, till I looked at Red Hat, we're using the UEFI type boot system, which goes onto the hard disk. The beginning of the hard disk has, instead of an MBR, it has a GPT, and the GPT then tells the system to go to just a special partition that's about 8 megabytes big. And that partition then has enough information that it can access the other partitions and start booting your system. It can load the kernel of your operating system and maybe some windowing software if you need it. And then it goes to System D, which actually it loads all the other stuff. MBR works pretty much the same way, except it's more limited on what you can do. It's less secure, and it works pretty much the same way though. Okay. Historically, there was a big battle here because when they first came out with the UEFI system, everybody had to pay a bundle of money to the UEFI gods, or you didn't get a security code that you needed in order to use this system. They wanted to secure your computers against unwanted operating systems. It was supposed to make things more secure. What they were, in my mind, what they were doing is they were trying to secure the whole computer world against Linux. Well, Linux people, I think Linux Foundation, or maybe it was the Linux Mark Institute, somebody bought some of these codes to give out to any distribution that wanted them. And so it didn't work. And nearly everybody that makes a computer has a firmware setting where you can turn on or off the need for those codes anyway. And we usually turn those off. So it's not a problem, but there were a few years we thought it was going to be a big problem. Okay. Now, there are various bootloaders around. I say Grub, and the only bootloader they talk about is Grub. But there used to be one called Lilo. I don't know if anyone uses Lilo or not anymore. Every operating system I've used in I don't know how long has always used Grub, but there are some other bootloaders around. I believe FreeBSD, OpenBSD, and NetBSD all use Grub. I think some of the proprietary Unixes do not use Grub. They use their own bootloader. Windows, of course, uses its own bootloader. If you ever build a dual boot system that will boot either Windows or Linux off of the same hard disk, at one time you really had to use the Microsoft bootloader. And then Grub has worked well for years, but I've read some things on the internet that say that Grub is no longer working so well to boot both Windows and Linux on Windows 11. I don't know. I have no personal experience with that, and I have no reason to run Windows beyond running it in a VM. So, and I even when I didn't use it on the same hard disk. I'd use separate hard disks. So so my experience is very limited on that. Okay, there is a question of how do you tell if you've got a system, how do you tell what bootload system it is using? Is it using GPT, or is it using MBR? Well, There is a command called parted for that, and which brings up a side light here. I told you that when you prepare a new hard drive, use G disk or F disk, but we really should be using G disk nowadays. And then use MKFS to format the disk. I notice the book says use parted. Parted does the same thing. I think they push parted because it's a little friendlier or something. I always use, I'm afraid I always use G-Disk. Parted is just as good. We've been using parted for the last 30 years too. I just personally don't use it much. Almost all of the installation processes from all the distributions actually they either use parted or they use G-parted, which is parted with a graphical user interface. But G-Disk works just as well. And I think most people that do it by hand, at least most of my friends use G-Disk. Anyway, this command will tell you what you have. Let's go down here where I'm on a system here. Okay, I'm on a system here. This is an OpenSUSE system. How do I know that's an OpenSUSE system? There must be a command for that. If you type cat space etc/os release on any, I won't say any Linux following reasonable standards, which is almost any Linux, it will tell you what distribution you're using. So I guess I'm using OpenSUSE 15.6 Leap. Okay, now let's do our parted command. Now, unfortunately, I've got like about 3 disks in this system. So we want to look at the first disk. This is the first disk up here is it's a solid state disk. It's the SDA. And in the system's booting on SDA, it's a 4 gigabyte disk. And right down here where it says partition table, it says GPT. Now, if that was an MBR system, like we will go over to a virtual machine here. I've got a virtual machine running Almar Linux here. This is the default that they give me. And if I type parted there, well, let me clear the screen. If I type parted space -L here, what I get is, it says partition type MS-DOS. Because the MBR system dates way back to MS-DOS, well before Windows. And so this is an MBR system. And apparently Red Hat's, this is all default stuff. Apparently Red Hat's default, I'm really surprised, but apparently their default is to use the MBR system. I'm really surprised that they're still using the MBR system, but it works good. There's nothing really wrong. It works good. It works good. It limits you to yeah, it limits the number of partitions you can put on a big hard drive a little bit severely. But then they're using LVM, so they, we just use the whole hard drive. So it's not a big deal. It also limits the size of the hard drive they can use, but I think those limitations are pretty large. So they're fine for that this year. Next year they may get caught. So, or maybe it's not even the default. I don't know. It's the default for a disk this size, but this is this is only a 20 gigabyte disk, hard disk. Maybe if you've got a 2 terabyte hard disk, they go with the GP. They go with the other style. I don't know. Oops. Back down here. Okay, the boot process of a system. When you boot a system, one of the things it does is it kind of comes up in Grub, and you can stop the system as it comes up in Grub and do some various things in Grub. Like, let's boot one of our systems here. We'll shrink that system. We're going to boot this system. It came up too fast. Well, actually, this is okay. At this stage, this will allow me to choose various kernels. I can also do a C, and I can get into the grub command line, and then there are commands that I can type in the grub command line that will allow me to make various changes and then boot the system or take it down after that. So there's all sorts of things you can do from the grub command line. And in practice, they're rarely done. You almost never need to do this. Once in a while, and when you do, you need to study it before you do it, because it's a rare thing. I never do this. Years ago, I think I had a few more problems, and I did have to do this sort of thing from time to time. This is also where I think you get a chance to boot your system in a single user mode for doing emergency repairs. And the book goes through that. I'm not going to go through that myself. The book goes through that, and you should go through this, in that it will allow you to boot into a single user mode and be able to edit your, change the root password, or edit your FS tab file if you have a broken FS tab file, or other files too. But suppose you forget your root password. This gives you one way of you can't recover your root password, but you can reset it. Okay. Kill that. before we had Grub, there was it wasn't straightforward how you did things like change your root password um, or repaired your FS tab file, but you could do it. The way you did it is you get a live Linux distribution, and you'd boot into the live Linux distribution, and then you'd mount your disk drives. Now, the two live Linux distributions, well, the one I've used and recommend for years is called Knoppix. Knoppix is, if you want to get it, there's a download Knoppix. At knopper.net. Now, this is a distribution written by Klaus and Adriana Knopper. It's been around for since at least 2000, maybe before that. They're Germans. They live in California. And they have this beautiful version of Linux. The reason I like Knoppix is it's kind of a Debian Linux, but it is designed to be ran as a live distribution. And originally, Klaus and Adriana, I was really impressed with them because they were among the first people around to be able to do just super good hardware detection. So the system detects all your hardware as it comes up. I know, everybody does that today, but around 2000, that was a real advance. Anyway, it's downloadable here at any of these sites. I'm slowly moving away from Knoppix though, because Klaus doesn't seem to be keeping it up anymore. The last version to come out, version 9.1, is 2 years old or more. And he did do a 9.2, but he published that in a magazine, and unless you buy the magazine, you can't get a hold of it. And I haven't gotten a hold of the copy. No, actually, I ordered a copy and they sent me a copy of 9.1. So after I paid for the 9.2. Anyway, it seems, I don't know what the future of that is, but let's go over here. Let's see. One of the nice things about Knoppix, just in general, is it has a billion different applications on it. It is really a full, complete Linux. It's a great Linux to run if you're going to, if you want to use somebody's computer and they're a Windows person and you're visiting, you suddenly need to use a computer and you want it to run Linux, and you can either run it off of a DVD, or it runs super well off of a thumb drive. Much faster, and it allows you to save your work and stuff on a thumb drive. Knoppix they've got a cool one-step program to put the DVD onto a thumb drive, and it's really great. You can also put it onto a hard drive, in which case it just becomes Debian. It's much easier to install Debian using the Knoppix installer, but I think it's a little bit broken. I don't think it's quite right, so I never do that. I just install Debian, but But Knoppix is a great distribution, and it's a good way to, show people the ins and outs of Linux. Um, let's see what it's got for, oh, like its Office. It's got all your Office suites on it. It's got the PDF reader. It's got a lot of security programs on it. It's got Inkscape. It's got, oh, this guy is for writing 3D, for making 3D, for making files that can print on a 3D printer. Scribus is like Microsoft Publisher. It's for publishing works. Anyway, it's just got a wonderful selection of hardware, of software on it. It's now, but back to the point, what I use it for is I use that if a computer's in trouble, I tend to boot on Knoppix, then I can mount the disk that well, here, actually, what this one is, oh, that doesn't show things right. Well, let's take our break now. I need to redo this after the break because this isn't very, very clear what's happening here. So let me take this down. And let's take our 10-minute break.
Initiating shutdown sequence.
I'll be back in 10 minutes. Okay, are we about ready? Well, let's see. I think I'll start here. Um, okay, going back here, what I want to say is it's really handy to have some sort of live distribution that works. A lot of distributions claim they have a live option. I think a lot of the ones that claim they have, like SUSE has, you can run SUSE, you can run Red Hat live, but they always strike me, or Ubuntu, but they always strike me that their live distributions don't live up to what they're supposed to live up to. They're not really, they don't really want you to use them as live distributions. They have made a live distribution, so they give you a little demo to convince you to reformat your hard drive and put their distribution on it, which is fine, but for a working distribution, that's not what you want. And I've used Knoppix for years. As I say, I think its day is coming towards an end. I still use Knoppix, but I and I think Kali Linux is pretty much a live distribution too. That is a real legitimate, honest live distribution. I'm going I'm going to try Kali Linux one of these days and see how that works in place of Knoppix for my uses. I have installed Kali Linux on a disk once, and it was okay, but I may want to. You guys who are in the security program, no doubt have more experience with that than I do. Since Kali Linux is used a lot by security people. Anyway, one of the things you can do, I mean, I say you could do, I have done many, many, many times, is instead of using Grub to bring the system up and fix lost passwords, what I've done is I boot the system using a live distribution. Then I mount the system's disk onto my live distribution using the mount command. Once the system's disk is mounted on my live distribution, then I have access to all the files under /etc. Well, it won't be a /etc/fs tab or whatever, because it will be at my mount point. If I mount the system's disk, I will probably mount it under /mnt on my live distribution. So what I will want to do is I will want to go in and edit the file /mnt/etc/fs tab, or maybe password. Well, no, not password. Where is the root? Where is the root? Where's the password for root kept? Or where's the password for any user kept? It used to be kept in the it used to be kept in the /etc/password file, but 40 or 50 years ago, we changed that, and it is now stored in the file shadow. So I would then go in and I would edit, if I lost my root password, I would edit I would edit /MMT probably, /etc/password, or /shadow, which is /etc/shadow on the system that I can't boot and log on it, or that I can't, that I need to repair. And that will give me that will look something like this. And if I read my man page correctly on the shadow file, there's probably a man shadow. I think I want 5, I'm not sure. Oh, and it tells me what everything is. It says the first item on the list is the login name. Yep, that's root. The second item is the encrypted password. So in between these colons here, all of this stuff is my encrypted password. So if I erase all of that and just simply have root, colon, and then the rest of the line, that will actually get rid of my password. And I will then be able to log in as root without a password. And that's been very successful for me. And that's one way of recovering a system where you lost your root password. The other way is to do it the way the book describes, which maybe is a little bit better, because the way the book describes is probably a lot easier if you have a complex disk, like your disk is BTRFS, or your disk is encrypted. The system I use will work quite well as long as your disk is not encrypted. If it's encrypted, I don't want to touch it. But this is handy for a lot of things. And of course, I could also edit the FS tab file. It's a useful technique. Oops, going back here. The last thing I want to talk about is run levels. Run levels are when your system boots. The way most of our systems boot is it comes up as, here's my Almar Linux system. It's got this funny graphical user interface. And that's cool. Let me boot another one here. We're going to boot another system. Okay, and then I log on. And it gives me this graphical user interface, which is cool if you like graphical user interfaces. But suppose I'm running a web server or a file server. Well, let's see, I got a file server sitting over there. I don't even have a monitor for it. Or a, a lot of, oh, heck, I loaned that to somebody. I don't have it. I was looking for a Raspberry Pi on my desk. Anyway, maybe a little Raspberry Pi that is running an irrigation system. I don't, it doesn't have a monitor. I don't really need a graphical user interface. So what I can do is if I log in as root, there's something called run levels. And the book talks about these someplace. Oh, probably not here. Yeah, the book talks about these run levels, and they use the systemd command to set your run levels, and that works just fine. And there are various run levels. You can be in graphical user mode, or you can be in multi-user mode without graphics, or you can be in a rescue mode or emergency mode. I'm not sure what that is. But anyway, the book sets these using the systemd command, which is a new, modern, non-Unix way of setting these. But on most distributions, the old system works just fine, and I think it will work for decades to come. And the run levels are listed and set. Let's see, I think here, the run levels, this is for Linux standard base specification, but you can be running SGI, IRIX, Unix, and these are the run levels. They're the run levels for almost all Unixes. It doesn't have to be a Linux. Run level 0 turns your system off. Run level 1 is single user mode. That's the mode you use when you're really in trouble and you just want to you want to edit your FS tab file and get the system repaired and booted back up. And you don't want any other users logging in. A run level 2, nobody ever uses. Run level 3 is the multi-user level where everything's running, but there's no graphics. That is the level used on almost all servers. Like if I'm running Facebook servers, they will be in big racks filling up a big warehouse in Redmond, Oregon. I don't know where Facebook is, but you know, all over, they've got spots all over the world. Well, maybe 6, maybe 10 spots, but and they're all in racks, and they don't waste their money on keyboards and monitors because you don't need those, and they will be running at run level 3 because who needs a graphical user interface if you don't have a monitor? And then run level 5. Oh, run level 5 is the graphics is what all your systems are running at with the graphical user interface. Run level 6, they say, is reboot. I guess that's cool. Okay, so let's go over here, and what we can do here is let me type. I think there's a command run level. I don't use that much. And you can just put in the number. But the traditional way of doing it is using the command init. INNT, run level works too. And say I want to go to run level 3. I don't know, does that tell me what the run level is? I don't know. No, it says I need a requirement. I guess I just need to know what run level I'm at. But let me type init 3. Okay, that takes me and puts me into a graphical mode. I can log on. And basically, you see I'm running a terminal, just like we did in the 1970s or 1960s. But that is all I need if I'm running a server. I don't need anything more, so, good chances are that's all I'm running. Now, I could become root, and a root can change run levels, so I can go back to run level, let's say 5. And there I am at run level 5. Oops. If I can remember my password. Okay. Become root. And let's see, let's try run level 6. I hope this reboots, I don't know. Hey, it's going down. Well, it should go down. And it's coming back up. And run level 0 is kill the system. So, now there is a default run level, and the system control command will let you set or reset the default run level. And by default, with all of our distributions, the default run level is set to 5, but you can change that and make it 3 or make it whatever you want. Well, I mean, it's pretty rare that you're going to want it to be anything except either 3 or 5. Maybe 1, though, because if your system is broken and you want to do a little bit of work on it, and people can log into your system from the network, then you don't want it to be up to run level 3, because run level 3 will allow people to log on. So you probably would go back to run level 1. And this will put me into what's called maintenance mode. In that mode, there's no background processes running. There is nothing going. There's no networking. There's no background processes. There's nothing except me. And what just happened to me? Well, I don't know. Anyway, that is the run level that you can do system maintenance at. It's rarely needed, but once in a while. And if I did init 0, that would shut the system down. And I'm going to have to just kill this system because it isn't working right for me. Okay. Going back here. Okay, that takes care of run levels. Let's talk about a couple other things here. We'll come back and talk about firewalls a little bit. Let's go to chapter 12. The book has a whole chapter on something called Kickstart. Don't take it too seriously. I don't use Kickstart. Kickstart's been around for probably 30 years. Here's my problem with Kickstart. What Kickstart is designed to do is, suppose I have my 100 Linux computers. And I want to bring up my 100 Linux computers and put Red Hat Enterprise Linux on all of them. Okay. Well, you installed Red Hat. It takes a little bit of time and trouble to install, and then you got to configure it to be just the way you want it configured, and maybe add some software. And I just brought up my OpenSUSE again, and it took me, a couple days. It's a pain to do this with 100 computers. So they have written a program called Kickstart that will help you, basically it automates the whole process. You bring up one computer, you use Kickstart, and you can bring up a lot of computers. What you do is you build a Kickstart configuration file, you ship that Kickstart configuration file to various places, you put in, I can't remember, you put in your master disk or your source material, you give the computer access to the distribution, you give it access to Kickstart, and it will do everything for you. Of course, not everything, I don't know if everything will be proper, because you usually don't want all the machines identical. They'll have different IP addresses, different names. Maybe you can do that within Kickstart. I'm not sure. My problem with Kickstart is a couple things. Now, I haven't used it in 20 years. I have used Kickstart, but it's been a long, long time. A long time. I don't think I've used it since before 2000. One of my problems with Kickstart is it only works for Red Hat-like distributions. Kickstart will work with Fedora, with CentOS, with Red Hat Enterprise Linux, with Almar Linux, with Rocky Linux. That's about it. There's been some attempts to make Kickstart work elsewhere, but they haven't been very successful. SUSE has its own version of Kickstart called AutoYacht, which does the same thing, but it's all different format. It's got little to do with Kickstart. I think Ubuntu has one called Pre-Seed, which again is very different, but it does the same sort of thing. I am reluctant to use any of those because they're so distribution specific. I don't like things that are that, usually don't like things that are that distribution specific. Okay, I like Yacht 2 on OpenSUSE. It's very distribution specific, so there are exceptions to that rule too. But that's my difficulty with Kickstart. Also, as I recall, with Kickstart, it installs individual packages, just like you would do if you were installing Red Hat. That's not so bad nowadays, but that when our computers weren't so big and fast, that was a very slow process. And so my alternative way, the way I've usually done things is I create a distribution that I take my Red Hat, I install my Red Hat on a machine, I then install QGIS and Grass and R and all this insane obscure software, Octave, I don't know, that my users want, because they're a bunch of geeky geographers. So I install all of that stuff. I don't put on many users. I don't put on, and well, I probably leave the networking as DHCP, get an automatic IP number. Actually, we use a lot of that nowadays. And oh, that's about it. Okay. Then I take that, I copy that to a DVD, to a thumb drive. Okay. That is my master distribution. I then go around to a PC. I boot the PC in Knoppix or some other live distribution, Kali Linux. I format my hard disk the way I want the hard disk, and I generally will have a script to do that. Just a simple Bourne shell that uses SGDisk and MKFS to format my the hard disk on each machine, which is easy if they're the same size. If they're not the same size, then there's a little fiddling to be done. But I'll have a script that formats. So I boot the machine in my live distribution. I have a Bourne shell that does all of my disk partitioning and formatting. Then it mounts the thumb drive that I made with the master distribution on it, and it just throws it down onto the hard drive. And then I have to go on to the hard drive. I have to boot the system and maybe add the users that are going to be using that system, or make a few, change the name of the system, change the IP number, or make a few changes of that type. Or maybe, okay, that's one way. Or maybe, and usually that's what I have to do, because usually I'm putting these on different clients' computers. So usually that's what I have to do. But if I'm doing this on a big operation like the computer lab at PCC, I would then have a DHCP server on one of the on a computer in the back room, and use that DHCP server by configuring that using the hardware MAC numbers on the network cards of each individual computer. I can tell each individual computer what its unique IP number is, what its name is, what its DNS servers are. When they boot that computer, that will all get downloaded from the DHCP server. So all of the uniquenesses to the individual computers get downloaded from the DHCP server, with the exception of who the users are. Users, they don't get downloaded, but everything else gets downloaded. So it's all centralized, and I don't need to do anything except for the users. But that's where you go back to what I was mentioning earlier, where you have the /home on the NFS mount. Now, that almost takes care of things, except there's also /etc/password file, /etc/shadow file. That's where the individual user and the user's password are registered on the system. Those need to be changed on every individual system, sort of. But actually, you can make those, and I guess I'm getting abstract here, but you could actually make those links that go to a centrally mounted disk, an NFS disk, that that has one master file for all of that. And those are then picked off the NFS disk, the shared NFS disk. I hope that kind of makes sense. I'm basically saying you can centralize the whole thing. And I find that a lot better than Kickstarter myself. I just find that faster and easier to do than use something that is going to be distribution specific because, yeah. Nowadays, though, the way we do things is all of us are using virtual machines, using, I don't know, VirtualBox or Proxmox or whatever. And what do you have to do if you want to replicate a machine using that? Well, instead of using Kickstart, what you do here is, suppose I need a new machine here. Clone my machine. Okay, that's the clone. We can rename it here, but we won't rename it. Actually, we will put a dash there, though. And do I want to do a full clone or a linked clone? A full clone means it will copy all the hard disk and make new hard disk for me. Or I can do a linked clone where it uses the old hard disk and only keeps the changes to my hard disk. So it's a little slower, but it uses a lot less file space. Include only network adapter MAC addresses. I think that's right. Now let's generate new MAC addresses. In other words, should that be identical hardware or should it have different network cards? Well, you really want different network cards because I don't want, if I have the same MAC numbers, the network's going to get screwed up because it's going to be trying to send and receive data from two different computers that think they're the same. Okay. And I have a clone. And then it's, so this is very, very much like the way I was saying I did hardware computers by putting them on a thumb drive and taking them from machine to machine. Well, this is the virtual version of that. And this is what everybody is doing nowadays, is basically you build a machine the way you like it. You keep that as a master machine. And then when you need a new machine, you never use that master machine. You always clone that machine and then make modest changes to the new machine to make it work the way for the specific use. And that's, in my mind, that's, you know, I guess what I'm saying is my own feeling is Kickstart became outdated quite a few years ago. But that's just my opinion. And it really is just my opinion. I'm sure other people feel differently. But, okay. So that gives me that guy. Let's go back to here. Okay, is that halfway clear on how to build new machines and do it quickly and efficiently? And you know, the truth is nowadays with these in the cloud setting, we're building new machines without user intervention. We're basically looking at the demand on our machines, and we build new machines as the demand. We write software that builds new machines as the demand that gets when we need a new machine, instead of having somebody actually sit there and make the decision that we need new machines. So it's gotten very automated. In my own usage, it's not that automated. I have to decide I want a machine, but yeah. Last topic is well, once again, their title sounds overwhelming to me. Manage network security. What is in this topic is in chapter 11 is really just firewalls and nothing else. There is more to network security than firewalls. There's data encryption, there's virus scanning, there's VPNs, there's a lot more than just firewalls. But they're talking about firewalls. Moreover, there are various types of firewalls. And the book talks about Firewall D, which is a packet filter firewall. Now, there are two types of firewalling type ways of handling traffic going in and out of a system. There are packet filters, and what a packet filter does is when a packet comes into a system, it basically says, is that an allowable packet? Should I reject it? Should I drop it? Should I accept it? So if a packet comes in and your packets are all addressed to certain port numbers, which are kind of channels. So if a packet comes into port 22, and 22 is the port that we usually use for SSH. If a packet comes into port 22, there's a piece of software there that says, should I accept that? Should I reject it? Should I drop it? Okay. And so if I'm sitting here on my web browser and I type in pdflinux.org, well, it's got to do a lot of stuff. But once it figures out, it's got to go off to a DNS, find out the address of pdxlinux.org and everything like that. But once it finds out that address, it then sends a message to the computer pdxlinux.org, says, I want a web page, and it sends that on port 80. And there'll be a firewall, hopefully, on pdxlinux.org, or maybe several firewalls, and it will say, oh, I accept request for web pages, that's okay. And then I think the systems negotiate a common port that's at a bigger number and they talk to one another. But so that's the process. So there's There'll be a firewall on pdxlinux.org. Okay. And the question is, if you want outside traffic coming into your systems, then you probably want to set up a firewall to protect your systems from everybody coming in. That's a packet filter. And, you know, they're good firewalls. We all use firewalls. But I want to say there are other types of firewalls. The book talks about the packet filters, but there are other types. One type is called a proxy filter. What a proxy filter does is I send a request like to pdxlinux.org. There's maybe a computer before it gets to pdxlinux.org, or maybe this is a daemon in pdxlinux.org. I don't, it can be either way. What it does is it reads the request for information from pdxlinux.org that I sent to it. It then reads that and says, oh, that's cool. I think I'll let him have that information. But he does not send my request on. Instead, what he does is that proxy firewall rebuilds the request and sends their own request to pdxlinux.org. They get the information back and then they send it back to me. So it doesn't actually send the things that I sent all the way to the web server. It rebuilds things going and coming. The advantage of that is if I send a misformed packet that's supposed to do some sort of a packet overflow or some sort of weird packet thing, the packet filter, since it rebuilds the packet, it will send a proper packet to the web server, so the web server won't get damaged by a misformed packet or anything like that. It can also do some really complicated things, like maybe when I send the request, I send it in English, and the proxy filter then translates my request to Mandarin, sends the request in Mandarin to the web server, which sends the request back in Mandarin. It then translates that to English and sends it back to me. I mean, it can do some weird things. Another thing a proxy filter can do is I send a request, I send some email out, in or out. It probably will do a virus scan on the email to keep the viruses off of my good computer. And if it's a government firewall, as what it should do, email constitutes a government record that is supposed to be saved, right? So if it's a government email server, maybe it should keep a copy of that record so that it has a copy of all email going in and out of the agency. This is what Hillary Clinton got into trouble about a few years ago. And had she had a proper proxy firewall, she wouldn't have gotten into trouble. Well, people wanted to give her a bad time. She would have gotten into things. but it would have been a more secure system. It would have been a better system. However, as I said earlier in this lecture, what we do on a home system and what we do on a professional system is somewhat different because it takes a lot of resources to keep all of that stuff, to design a system like that and keep it up and going. More than most of us have as home users. Okay, well, we're getting low on time here, so I will say the book describes Firewall D. It does a good job describing Firewall D. That is one system used for firewalling. It is used in almost all the Red Hat world. It's even used in the OpenSUSE world. SUSE had a terrific firewall and they've decided Firewall D is better, so they're using Firewall D now. In the Debian world, people like Ubuntu, Linux Mint, all of those people use something called uncomplicated firewall. I'm not as familiar with it. And both of those are packet filters and packet filters only. If you had packet filters are good, and it's nice to have packet filters, a packet filter firewall on most of your computers because they're cheap, they're easy, they're good. But for your house, for your corporation, it's nice to also have a corporate firewall or a departmental firewall. That is a separate computer that is running firewalling software that can do things like packet filters, proxy filters, virus scans, set up virtual private networks if need be, and things of that type. And there are Linux firewall distributions that are just built for firewalling. Now I want to show one diagram before we go here. This is the way a typical company is set up. Now, this was used a little bit in a networking class I taught, and it's not quite right, but suppose this out here is the internet. Then a typical company, what you have is you put in a firewall here, and then you have your corporate servers down here. Well, you have the servers down here that people have access to. So like your FTP server, where you let the whole world come in and download software that you're giving away, or selling, that would be on something called the DMZ, the Demilitarized Zone. Your web server would be down here, or nowadays we might put it in the cloud and just let somebody else handle it. But if you're doing it locally, it would be down here on your DMZ. Your Jetsu server, which is an open source equivalent to Zoom, would be down in here on your DMZ. The firewall will have multiple network cards in it. So it's got, let's say, 3 network ports. One goes to the outside world, one goes to the DMZ. So the wiring all your wiring is separate. And one goes to your internal zone, all your internal computers. That would include things like your file servers, your database servers, the ones you don't want anybody to have access to, and all of your workstations. And now those will be on your internal zone. And then you'd put in a good firewall in here, which, you can buy pre-built firewalls, but all they are is their software put onto a funny looking computer. And so a lot of those are Linux distributions, And if we go back here, there's a lot of, well, there's a lot of Linux distributions for firewalling. There's all sorts of them. There's one that I used to use called Smoothware, a Smoothwall. Smoothwall was very simple, very good, and it did an awful lot of things, even setting up VPNs and stuff for you. Unfortunately, it's no longer maintained, but it has been forked and replaced by something called IP Fire. I think that's a pretty good firewall, and it's an easy firewall. There's another one called OpenSense, and really, there's 24 of these firewalls. I'm only listing a few that I think are good, but there's many that are probably good. There's one called OpenSense. OpenSense has a reputation of being really good. I've never used it. There's one called PFSense. PFSense is the one I've been using lately. It's really comprehensive. It's if it's got one flaw, it's a little bit too complex. But it doesn't have much for a flaw. It's a really good firewall. It's actually not based on Linux. It's based on FreeBSD, but it's a good firewall. I'm told that OpenSense is a lot like PFSense, but I've never used OpenSense. There's also one called Sophos. Sophos used to be called Astral Security Linux. I used it when it was called Astral Security Linux. And everybody that worked for the company was German. And we sold them in America, the company I worked for. It was a great firewall. That was a long time ago. I assume Sophos is equally good. Sophos purchased Astral Security Linux, but I think it's a good firewall. If I were to set up one tomorrow, I'd probably use PFSense because I like it. And there's a lot of good firewalls out there. As Linux or FreeBSD distributions. So my final thing is, if you're going to set up a corporate firewall, don't do it on Red Hat, much as they may recommend. Get yourself a good firewall distribution and use it. If you're just trying to firewall your computer, Firewall D is great. The chapter in the book is great for that. And actually, I use Firewall D quite a bit. But for my corporate firewalls, I use something else. And I really do recommend using something else because a packet filter just is not sufficient for the attacks we have today. And the more things your firewall can stop, the fewer problems you have to stop on your client machines. So you really want to get things early before they get into your network. They get into your network and it's a pain. So, okay, I will take a 5-minute break, but I will be around till noon. And I think that's everything for the day. Anybody have any questions? Okay. How you doing, Ajay? Okay, I'm going to stop recording now.